So let's go ahead and get started talking about how you can turbocharge your configuration engine. Today, we have four key areas that we're going to talk about on our agenda. The first is the evolution of choice. It's going to be a very fun, informative historical lesson, and we're going to talk about how choice has evolved in the automotive industry, going from the Ford Model T all the way to the Tesla Model 3. We're going to talk about some of the challenges that manufacturers face whenever they have to manage complexity and configuration. We're going to talk about what that costs your organization, such as performance, loss of revenue, and a bunch of other criteria. And then finally, we're going to offer some really keen insights on how you can turbocharge your configuration engine throughout this process. So let's go ahead and get started on the evolution of choice. So when most people think of the Ford Model T, they think about it as you can get any color you want as long as it's black. Well, in reality, the first version of the Ford Model T, 1908, 1909, actually came in four possible color combinations. Now, this went against what Henry Ford wanted to accomplish. He actually wanted to be able to offer an affordable automobile to the public. So this offered a few challenges by offering the complexity and offering the configuration combinations. So that's when we saw in 1914, 1915, this Ford Model T came about in one possible combination, only in black, the windshield was included, and you really didn't have any choices at all. Now, what was interesting is Ford saw that a lot of after factory installed options were getting installed. So a lot of customers would go to a service station and actually get rear lamps. They would actually go and get a speedometer installed aftermarket. And so he realized that customers needed choice within their designs. And so that's why in the 1920s, that's when the Ford Model T started to come out of that same combination. However, because of the assembly line process, he was able to keep the costs relatively low for the average consumer, but be able to handle all these complex variations. So it was quite an advancement from that perspective to be able to offer complexity, but still keep it affordable for the user. Now, if we were to jump all the way forward to 2022, that's where we hit something kind of on the extreme. We find the Porsche 911 in 2022 with 700,000 base combinations. Now, once we factor in color combinations and upholstery, it's virtually unlimited. So it's really the ultimate expansion of choice and being able to understand what is possible from a manufacturing perspective. But key thing to note here is almost 7 out of 9 are custom made. Then we look at a different example. The Tesla Model 3, the 2025 version, has only 36 possible hardware permutations. Now, they have a lot of software permutations, but those are unlocked through keys. What's interesting here is Tesla Model 3, it might be setting a trend in the industry where they are steering away from customization and going to more standardization. In fact, something very interesting is happening with this. You may or may not know this, but Tesla actually has, from the automotive industry, one of the highest operating margins. So the question is, if you're currently in a situation where you're the Porsche and you're offering unlimited permutations, unlimited combinations to your users, how do you go from one extreme to kind of the other, where you start to offer more of a centralized product offering? Well, let's take a look at this as we see it over time. So when we started out, like I said, we had the Ford Model T. It had a few options, went to one. And then, of course, it started to explode. We had a couple of evolutions of this in the 50s and 60s. And of course, in the 90s, it really took off. But we hit a big challenge. In 2020, we had COVID. And that's when we started to see challenges to supply chain, inventory, skyrocketing costs for manufacturers. And we're starting to see a trend now in the market where manufacturers want to minimize the number of permutations that they offer. So the question is, how do you do this? How do you manage all of these permutations? Well, there's a big factor here at play. And this is something I like to call complexity burden. Complexity burden, if you look at a line going from the curve down to the zero axis, that is the number of permutations that your organization is currently supporting for a product offering. But there's something else as well. If you go from supporting 1 million permutations to 10 million the next year, that's going to be a very steep curve on the timeline. So complexity burden is not only the number of active permutations you have to manage or solve for, but it's also how steep is that curve. Just like that guy is carrying that car up the hill, I'm sure you can imagine the steeper the curve, the harder the task. And that's what your organization has to deal with. So let's talk about some of the challenges that we might see in the organization and in the industry. Real quick though, I did want to mention Configit. For those of you who may not know who Configit is, we have offices located, our headquarters is in Denmark, and then we have offices as well in the US, Germany, UK, and India. We have nearly a quarter of a century in solving complex configuration challenges. So we are definitely the leader in configuration lifecycle management and solving the most extreme complex configuration challenges. We're owned by Polaris Management, over $1 billion in investments. And then of course we have a very strong partner network, PTC, Unity, NVIDIA, PwC, Infosys, and many more. But the one thing I wanted to point out is this particular tech talk may be focused on the automotive industry and may have a lot of car references, but we actually cater to the world's largest manufacturers. From automotive to industrial, agricultural to consumer-based, we really cater to the world's most complex challenges in a configuration environment. So what are some of those challenges that we've helped manufacturers overcome? Well, some of the big ones here we see is the sheer volume of combinations. And the challenges that come with that is you have to identify false positives. So what that means is you may have all these possible permutations, but how do you understand if you can actually build it and if you can actually service it? And then of course, with all of those combinations comes the inventory you need to have to be able to support those variations as well. Obviously, more permutations equals more inventory. That's always a big challenge for manufacturers. The second big one we always see is the number of rules and calculations. We had one particular customer who had over 500,000 engineering rules. So how do you manage that? That's going to have quite a heavy tax on your performance for your servers. And of course, how do you validate those configurations to ensure that the rules and all of the calculations are valid? Then of course, there's dependencies between all of the different components. Today's world is incredibly complex, and what we see is not only do we just have hardware that has to play together, but we also have hardware, software, and firmware from all the electronics that we find in our day-to-day lives. And of course, that means you have to manage the compatibility and you have to support them from an ongoing perspective, which leads to engineering change requests. Being able to support your products over the life cycle of the product for end of life management and to be able to do service, maintenance, and upgrades. So let's take a look at one particular example. Inside of automobiles, there's something called an ECU, or an electronic control unit. Now in the 80s, this was relatively simple. We had roughly 1 to 5 engine controllers, anti-lock braking systems, emissions. It was pretty simple. But then we started to incur this exponential increase in the number of ECUs we found in our cars, whereas today we have upwards of 150 plus ECUs. So it becomes a bit of a challenge, but it becomes even more of a challenge when we start to look at managing versions. So in this case, we have an engine controller on the screen. If we have to manage the hardware, we make a change to the hardware from V1 to V2, maybe we add an additional socket, maybe we change the radiator fins to transmit heat. Now we have potentially a whole bunch of different ECUs that we have to manage from that perspective. So it could, instead of 150, maybe now we have 300 if every piece gets revised. But like I said, it's way more complex than that. We also have to account for firmware and software in some cases. And so as you can see, when we map out all these possible variations that we have to support based on what hardware component is in the car, based on what firmware and software is loaded onto the chips, it really creates this complex scenario that you have to manage. Now, if you find this construct very interesting, I would highly recommend scanning this QR code either now or once you get a copy of the recording. It is by Heiko, and he did a tech talk in the past called Effectively Manage Configuration Changes. This is really great, especially if you have a very big service, if service is a big part of your industry. Being able to manage those changes over time so that you can ensure your customers get the proper parts, the proper software, hardware, firmware. It's a really key ingredient in this whole discussion. So what happens if you don't do a good job of managing this? Well, that is the cost of complexity. So there's a lot of costs that we actually see here. Some of them are pretty obvious, some are a bit hidden. So here's all of the challenges that we identified previously. Identifying false positives and supporting all that additional inventory from the sheer number of permutations. That means you're going to have suboptimal margins, and that's a big challenge. How do you ensure that you improve your margins, but still be able to offer all of the options for your customers? That is quite the challenge. And then of course, with performance concerns and being able to validate all the number of rules, all the number of calculations, that means you're going to have higher operating costs. You need to be able to buff up your server so it can handle the load, handle the number of calculations it has to manage, and of course, have a higher QA budget so that you can test and validate that you're not going to have anything incorrect inside of your configuration environment. And then of course, for component compatibility, support, and documentation, that means it's a longer time to value. So as you support all these different variations, as you be able to adjust and pivot, that means you're going to have to invest a lot more into the product before you hit your ROI. And of course, end of life management and service and maintenance. If you're spending time maintaining all of these variations, that means you're not going to be able to spend time investing into innovative resources, new products, advancements in technology, and so forth. So there's a lot of obvious ones here, but there's also a few hidden costs as well. So the real question here becomes is, how do we turbocharge your configuration engine? Obviously, you can't just remove all the options. That's not ideal. You still need to be able to support your customers. So let's talk about some of the ways we can help you to turbocharge your engine. So to manage the increasing product complexity, when we relate it to complexity burden, right, going up that steep hill, managing a lot of new variations, the best recommendation for that is to utilize a modular product architecture. Have a set of building blocks that you can reutilize, and when you add new products, use the same sequence so that you can quickly add or remove as needed. To manage the sheer number of combinations, not just from a manufacturing perspective, but also from a user perspective, that can be very overwhelming for you, your sales team, and your customers. That's where guided configuration will really come in hand. To manage all of the dependencies, that could be data sites, that could be all of the different timelines and product data. You could leverage configuration lifecycle management. And then to help strengthen your margin, that's where you want to analyze and optimize your product portfolio using something we call solution space. Now I'm going to go dive into each one of these so we can get a little bit more benefit into understanding how these work and how they can benefit your company. So for the modular product architecture, like I said, we're going to create all these building blocks that we're going to use to be able to build out a virtual library of your components. The first thing you want to do is identify commonality across the product variations. So in a car, maybe the frame doesn't change. We won't talk about adding spoilers in this case, but maybe the frame stays the same, maybe some of the structure. Then you need to identify what does change. Identify the dependencies and variances. So in this particular example, maybe you have different tire sizes, different rims, different dashboards. Maybe the engine can be swapped out for a different engine type. Now, what's interesting here is you also need to consider the dependencies. So if you have a choice on engine size, maybe that requires a different mounting bracket. So you need to include that mounting bracket in with those dependencies. Otherwise, it'll just get lost in translation and you may miss something and not have an accurate bill of material. So the final thing you want to do here is you want to group the options by functionality, manufacturability, which allows you to create these phantom assemblies and packs. Now, you could Google these if you don't know what they are, but they will help to ensure to maintain your bill of materials, to help you to be able to cluster all of your data together so that you can more effectively manage your configuration data. And of course, as a bonus, once you've got a modular product architecture in place, you can minimize unique parts. That'll greatly help. And that's something you can do with solution space, which we'll talk about later down in the presentation. So from a modular product architecture perspective, some of the big benefits here is it offers a scalable framework, not only for configuration, but also from a manufacturing perspective as well. You get dual benefits from doing this exercise. You can also respond to market dynamics. So if you make everything a set of building blocks, you're able to respond very quickly by clustering objects together so that you can either add new product variations or remove product variations. Because can you imagine scanning through all of your bill of materials and being able to find part numbers and pulling parts out? If you just have a phantom assembly, you can do it all in one. And of course, one big benefit as well is it promotes inventory awareness. You'll better understand how your inventory is interconnected between the product options, and it'll help gain insights into how they're related. The next one on the list is guided configuration. Now, this is unique to Configit. Guided configuration is the ability to make decisions and have a 100% accurate or error-free configuration. So traditional configuration engines offer dead-end systems, where if you make a choice, it'll force you into an area you may not want to go. Within guided configuration, when you make a selection, if there is a conflict that needs resolved or something that needs your attention, it will advise you what you may have to do or what you may have to offer your customers or salespeople in order to have an accurate configuration. So this is actually incredibly beneficial, not only to you, but to your users. For the users, it's benefit for all experience levels, whether you're an expert user or whether you're someone new to your product offerings. Guided configuration helps guide you toward the options that you care about the most. And as far as the benefits to you and your organization, well, the big one, I think, is it minimizes the intervention between sales and engineering. If you can guide your customers and guide your sales reps toward a decision that they value the most without involving sales and engineering on a reoccurring basis, that'll simplify the number of ETO variants, especially if it's a matter of needs versus wants. So by transitioning from everything goes to let's guide you to the best fit for your needs, that's really going to help benefit you and your organization. And all this, of course, means it's 100% accurate results with very little or no property mapping to be able to understand how these are related to each other. The next item would be to leverage configuration lifecycle management. This is the birth of Configit in a sense. Configuration lifecycle management helps you to pull all of your data from multiple sources. It helps to streamline all of the data across your different systems, whether that be your CRM, your PLM, your ERP, and even another CPQ tool. We offer an integration that you can utilize to be able to pull all of your data from all these independent sources so you don't have to copy and paste data from your independent sources into your CPQ tool. It also allows for really great collaboration between your different departments. So sales and engineering can work together and of course involve manufacturing and the often left out service. That's kind of the key. Configuration lifecycle management allows you to manage your configuration data over time by ensuring that you have 100% compatible parts across your system, which is really great from a service perspective because we all know how many times you've taken your products to go get serviced, they either don't have your part in stock or they find out there's something wrong and there's something incompatible and you need to make a change on the fly. The last thing here is the analysis and optimization of your product portfolio. Something else that Configit offers that's truly unique is something that we call solution space. Solution space involves understanding all of the possible valid permutations inside of your product offering. So if we were to look at the image on the left, that may represent all of the permutations that could be configured, but maybe only a portion of those are actually buildable. Utilizing our solutions-based technology, you can also go one step further and understand what is orderable. Maybe you don't want to sell certain variants and what you want to actually sell. So being able to understand all of this is possible, and it offers a wide array of benefits. The first of which is you can use it during configuration runtime. So while the users are using your configuration tool, they can utilize solution space to understand what are the possible options that meet all the criteria they have. And you can also use it from a post-configuration analysis perspective to understand all of the valid permutations that exist. Did a demo a while back where a customer kind of questioned, well, can you really do that? And we did a live demo where we calculated out, I think it was 12 million possible permutations. So it was pretty impressive from a live demo perspective to be able to showcase that on the fly. It also allows you to understand configuration prevalence. What is the likelihood of a particular option either coming up, being ordered, or being pulled? So it really gets you a much better insight into your inventory, a much better insight into how your product is being consumed by the users. And then finally, solution space will help to identify product combination margins and low runners. So I'm sure you can imagine if you correlate this with your ERP data, you're able to understand very quickly how these are from a margin perspective and which ones you should potentially get rid of if they're costing you money or if they're just too much pain to manage. And of course, all of this is possible from our virtual tabulation technology. So some closing thoughts on this. When you're considering configuration complexity and managing it, there's a couple of key notes here. The first is complexity is double-edged. We all know we need to support our customers and be able to offer all of the options that they feel they need. But that means it also impacts you. The more options you offer your customers, the harder it is to manage from your perspective. It creates more work. But what's interesting is not managing that complexity is actually even more expensive than doing it as you're doing it currently. It makes more sense to invest in a product that can manage the complexity at scale and be able to help you with that. So as you add new variants, as you make changes, as you evolve your product over time, being able to understand how that impacts your business. And of course, guided configuration produces a win-win scenario. So as we saw earlier, being able to offer guidance during the configuration process is amazing because it benefits the users, it benefits your customers, it benefits your organization because you may be able to offer something for the right price, in the right time, to the right customer. And then finally, a strong configuration engine enables scalability. Not just from a scalability to add more options, but also a scalability from performance. Our virtual tabulation technology enables us to get some of the best performance when it comes to configuration. And that's because we are the global leaders in understanding complex configuration challenges. Thank you.
Great, thank you, Tom. We do have a few questions, and I think we have about 4 minutes. We can take a couple of them. Um, First question, how do you recommend companies prioritize which configurations to offer, especially when there are so many potential combinations?
That's a great question. So what I would recommend is understanding how your product options influence other items. So I talked earlier about the engine block. You know, the engine gets mounted using certain bracket hardware. Understanding how all the dependencies play together is pretty key in understanding which ones are your low runners and which ones you should focus on. And of course, if you have access to all your ERP data, you can do a cross analysis with that utilizing our solution-based technology so that you can understand the margins, you can understand the impact on your infrastructure and of course, inventory as well.
Great. Have time for one more. I'll pick this one. You mentioned managing hardware, software, and firmware versions, but you didn't mention how that was done. Can you please provide some additional insight into the how?
Oh yeah, absolutely. So being able to manage the configuration lifecycle management portion of hardware, software, and firmware is actually native inside of our technology, inside of our software. And that is through the use of effectivity. So effectivity is assigning dates and times to different options. And over that, I'll actually pull the slide back up real quick. You are able to utilize a time frame that ensures that you have a 100% accurate configuration for that particular scenario. So looking at what was ordered, what the customer currently has, either due to service upgrades, maintenance, RMAs, and of course, that offers a lot of key insights into the technology. Now, I don't have time to explain it in full depth, but I will say this, scan that QR code right there. I think you'll find this a very informative tech talk.